Hello, this lecture is on z-scores. I actually really like this topic because z-scores are very helpful. They bring statistics to everyday application for things that you will see all over the place. So I'm excited to talk about it and share it with you all. All right, so same format as the previous lectures. We'll talk about why we need z-scores, what is it, when is it used, and most importantly, how do you compute it? And of course, you're watching this accompanying YouTube video or recorded video. I'm not sure it'll be on YouTube, but it'll go along with the slide. All right, so why do we need z-scores? So far, we've been working with x-scores. So x-scores are just the raw scores or the x-scores that you see on a data set. It could be a list of ages or weights or GPA, etc. Sometimes those values are meaningful. Sometimes they're not, though. For example, if you consider, let's say you're in a study with 200 people and everybody's asked to rate their happiness level on a scale of 1 to 30, 1 being not happy at all and 10 being extremely happy, and you put yourself at a 20. So what does that mean exactly? How happy are you? Does that mean there's a value of 20? I said 21 here in the example, but it should be 20 actually. Let me change that. So does the value of 20 mean that you're happier than the other people in this 200 people study? Does it mean you're less happy? Does it mean you're about average level of happiness? You don't know. You can't answer these questions with just the x-scores alone. That's why it's important to standardize the x-score. Standardizing means you're taking your score and you're comparing it to all the other people with similar scores on that variable. So in this case, the happiness score. You're taking your score and you're seeing how other people rated their happiness, and you are comparing yourself to those people. So in the above example, you don't know what a score of 20 means, but if you know that the average or the mean happiness score for the group is 15, and you know that the standard deviation is 5, then you know your score of 20 is just above the average. It's about 1 standard deviation above the average, because if the mean is 20 and the standard deviation and the mean is 15 and the standard deviation is 5, then you know that your score of 20 is 5 plus 15 is 20. That's 1 standard deviation above the mean. So this basically means you're probably in the average range or just slightly above happiness level compared to the other people in this sample. So a question that we can't answer just yet is how much more happy are you from the rest of the sample? For example, what is your percentage level as far as how happy you are in terms of percentile? Are you in the 50th percentile, meaning you're happier than 50% of the people in the sample? Are you in the 90th percentile? Are you happier than 90% of the people in the sample? We don't know the answers to that yet, but with z-scores, we could figure it out. That's why z-scores are very exciting. All right, so a z-score basically specifies the specific location of each x value within the distribution. So what the precise location of the x value within the whole data set of, in this case, all 200 people. The sign of the z-score signifies whether the score is above the mean or below the mean. So z-score, usually at the mean, the z-score is 0, and we'll get to the above and below in just a minute, but just know z-scores could be negative or positive. The numerical value of a z-score specifies the distance from the mean based on the number of standard deviations. So we'll discuss this in further detail in just a minute. So just like I was saying earlier in the previous example, if your z-score is 20 and you know the group's mean happiness is 15 and the group standard deviation for the happiness variable is 5, then that means your happiness score had a z-score of +1 because a z-score is similar to a standard deviation. So a z-score +1 means +1 standard deviation. So you see here, this is the mean of the group. This is standard deviation of the group. If you add those two together, you get 20, which is your score, which is 1 standard deviation. Okay. All right. So how do you compute z-scores? All right. Um, I think we must be missing a slide here. Yeah, we skipped a slide. That's why. All right. Because we were here. When do you use it? Oh yeah, we skipped the last slides actually. What is it? When is it used? So z-scores could be used with any type of distribution. You remember when we plot a set of scores or a variable on a histogram, we get to see a lot of different shapes. A normal curve is the symmetrical one where it goes like this, where it's even on the left side and the right side. A positive skew it's the same thing as saying a left skew because all the no right skew because all the values start very low for the first few and then it stacks up very high as it reaches to a higher value. Then you have negative skew as well. So these are all just different distributions that a variable could take. And z-scores could be used with any of these distributions. And z-scores used anytime you want to standardize a variable. So standardization means you want to find out if one particular score, for example, my score or your score on that happiness variable, how that compares to other people. Is it within the average range? Is it below average? Is it above average? So that's important to know. And z-scores are used in a lot of real world settings. They're used in a lot of standardized tests. For example, the LSAT, SAT, GRE, the MCAT, they use z-scores to rank students. What they do is students take the exam every year. They have their raw scores, which is just the number that they get right. There's the number of questions they get right. And then you can use these scores to basically compare all these students to each other and put them on a ranking to see whether they rank first, second, in the first percentile, second percentile, all the way up to the 100th percentile. For example, right now, if you had, I think last year perhaps, if you had a score, an SAT score of 1250, then that puts you at the 81st percentile. How did they figure that out? How do they know that 1250 equates to the 81st percentile? So the way they do that is by taking all the students' scores. So there's 2.13 million test takers from last year, and they took all their scores, and then they basically convert them to z-scores, and then convert the z-scores to percentile ranks. And we'll learn how to do that today. Z-scores are also used by many psychological tests, such as IQ tests, mental health surveys like depression, anxiety, substance use. It's also used to diagnose many psychological disorders as well. Yeah. So the reason why z-scores are so commonly used is because with a lot of these measures where you're measuring something like, SAT is measuring like aptitude, the MCAT is measuring, knowledge about medical stuff. I don't know. LSAT is measuring knowledge about law stuff. These are all variables, right? Like law knowledge is a variable. And the thing is, the only way to decide who to let into a certain program based on, let's say, our LSAT score is to compare them to each other, compare students to each other to see who ranks higher. And so in order to know those rankings, you have to use these scores. So how do you compute a z-score? So there's two approaches listed here. One is the formula approach, and one is the Google function approach. So the formula approach is a straightforward formula. There's basically only, if you want to compute a z-score right here, converting from X value to Z score. You want to compute a Z score. All you need is the one X value, the mean of the sample, and the standard deviation of the sample. So you only need three things for the Z score. You only need the X value, the mean of the sample, and the standard deviation of the sample. So Z score is the X value minus the mean of the sample all over the standard deviation of the sample. You could also reverse it and calculate the X value if you have the Z score as well. So if you want to compute the X value, all you need is the mean plus the Z score times the standard deviation of the sample. Again, that's the single X value equals the mean of the sample plus the Z value for the associated with the X value and the standard deviation of the sample. And you can always also switch this formula around to compute the mean if you have the Z score, the standard deviation, and X, or if you want to compute the standard deviation from the X and the mean and the Z score. Usually you don't usually need to compute the mean value or standard deviation value. I just put it here just for demonstration purposes, but this is very rarely asked about in practice. Usually they're asking about the Z score, compute the Z score, the X value. This is helpful if you are computing a single Z score. So let's say you have a question asking, what's the Z score? You know, you have your score, my score on the happiness value is a 20. What is the Z score for that? So this, you can use this formula for it. So here's the example. If you have and I could do this I could do this in the Google Sheet, so to demonstrate. Okay, so let's say we have, I want to paste the problem here. That's ugly. I'm gonna paste special, paste values only. This keeps the original formatting. So here you have a mean of 100, standard deviation of 10, and an X of 130. What's the Z score? So you remember Z score equals X minus M all over SD. So what is, you plug the values in, what is X? X here is 130. You have to put the parenthesis. Minus M here is 100 all over the standard deviation, which in this case is 10. All right, you see here that it doesn't compute it yet, because you had to, if you want Google Sheets to compute it, you have to start it with the equal sign. So I'm just gonna copy this here and put it over here, double click, paste, and since it started with the equal sign, it's gonna compute it for me. You get a value of 3. This is what we got here as well. All right, let's look at this example. You have a variable that has a mean of 100, standard deviation of 10, and a Z-score of 2. What's the X value? So let's again put the formula. First, X equals mean plus Z times standard deviation. So let's plug in the numbers. What's the mean? The mean here is 100 plus what's the Z-score is 2 times standard deviation. Standard deviation is 10. And that's the format. And you have to copy, starting with the equal sign, and paste it into a new cell for Google to compute it. Z-score is 120. So if you have an X score of, what is it? No, if you have this is the X score. If you have a Z-score of 2, the X score is 120. And if you have a X score of 130, the Z-score is 3. And you see here the answer matches this one that I already computed for us. Let's go back. All right, so, okay. So let's look at this example here. You see here the mean is 100, standard deviation is 10, and X is 130. This parallels this graph here. This is a normal distribution. Remember, this is basically just a histogram of scores where it's symmetrical with the left side matching the right side. It's the left side is symmetrical to the right side and makes this normal, it's called normal curve or normal histogram. This is going to happen a lot. So I'd like for you to be familiar with it, to be familiar with this specific type of histogram, the normal curve. You see here, the mean is 100. So the way to read this is, here's the X value, as you can see here, X, down here is Z. So the X value right here, the mean is 100. That means most people have a value of 100 for this variable, this X variable. And you see here, the standard deviation is 10. So this line here is the standard deviation line. So you see here, when the mean is 100, the standard deviation is 0. When the standard deviation is when the standard deviation is 10, so if you add 10 to the X score, you get 110. That means you have one standard deviation. If you add, if you go one more standard deviation, you add another 10, you're at 120. And if, let's say you have the mean and you want to go negative one standard deviation, you just subtract 10, because remember, one standard deviation is 10 in this variable. Then you get the X is 90. If you subtract two standard deviation, then you have 80. So Z-score is the same as standard deviation. So you see here, the Z, when at the mean of the variable, of the X variable, the Z-score is 0, just like 0 standard deviation. When you move up 10, when you move up one standard deviation, you have one Z-score. When you move up two standard deviation, you have two Z-scores. And you can go in the other direction as well. When you move down one standard deviation, the Z-score is -1. When you move down two standard deviation from the mean, the Z-score is -2. So Z-scores and standard deviations are the same. Just keep that in mind. Okay. So we just learned how to compute a Z-score for a single Z-score. In this case, if you looked at the mean is 10, the standard deviation is, the mean is 100, standard deviation is 10, and you want to know what the Z-score is if you have an X value 130. So let's look at this. If this is, if one standard deviation above the mean is 110, two standard deviation above the mean is 120, then three standard deviation above the mean is another 10, so it has to be 130. So that means 130 is the X value, and the associated Z-score would be 3, right? Because you go 1, 2, 3 standard deviation. That's what we get here. What is the Z value? The Z value is 3. And if you look at this one, just to see how it applies to this graph, to this histogram, if it means 100 standard deviations 2, and you have a Z-score of 2, what is the X value? The means 100 standard deviations 10 and Z-score is 2. What is the X value? Okay, so you look here, if the standard deviation is 2, X value, you go up and down the line, X value has a Z-score of 2, standard deviation of 2, X value has to be 120. So you see here, the value is 120. All right. So how do you compute a Z-score in Google? In the Google Sheets. There's no Google function, even though I say it's the Google function, but it's no Google function. It's actually just a formula that you would plug into Google, which is what we did earlier. We just take the X value minus the mean as sample all over the standard deviation. So you remember back here, this is what the value is. Take the X value minus the mean over standard deviation. And that's what we did here. X value minus the mean over standard deviation, and we get the answer. This Google function value is helpful when you have a whole data set and you want to compute more than just one Z value. And so we'll see an example when we might use this in just a moment. Okay. So how do Z-scores relate to percentiles? I said earlier that the standardized test could convert a test score to a Z-score and then to a percentile rank, which is the same thing as percentile. So once you have an X score and you turn it to a Z-score, you could turn that Z-score into percentile rank. And see here, I put a star here just to indicate this is important to learn. So a rank, how do you define a rank? It's just how your score compares to others on that particular variable. All right, and there is a manual method involved in this, which involves like a long table where you basically you have a z score, and there's this huge table where you have to just match the z score with the associated percentile rank. And I'll show you. I guess I'll show you later because it's kind of an old school way, which people are still learning, so it's really not that old school. But I'm going to show you a more efficient way to do it. Let me show you the old way. This is how people used to do it. They would have a chart like this: z-score percentile. So they'll have something like this. They will see, okay, I have a z-score of negative 2.8. What is the percentile rank? Oh, it's 2.6. I have a z-score of, 2. Let's look at the z-score of 2. What's the percentile rank? It's 97.72. Or I have a z-score of 0. What's the percentile rank? 50. 0 is always the 50 percentile rank. That's just, you'll come across that a lot because it's the halfway mark. So this kind of old school way where you have the z-score and then you look on a table like this to see what is the percentile rank. So let me show you the new school way of doing it. The new school way of doing it is just by using whatever software you're using. So we're using Google Function here as our software. Oh, and just to mention, that table with all the ranks is similar to this chart we see here. So you see here, here's the z-score right here, and these are the percentile ranks. So you look at the z-score, the z-score is down here, the cumulative percentage. These are the ranks. So you look at z-score of 0, remember the 0 is 50 percentile. You look at the z-score of 1 is 84.1 percentile. You have a z-score of 2 is 97.7 percentile. You have a z-score of 3 is 99.9 percentile. So this table is just to show you how z-score and standard deviation are related to percentile rank. And you see here z-score and standard deviation is the same. See, you have +1 z-score, you have +1 standard deviation. Okay. So how do you turn a z-score into a percentile? You basically go into the Google Sheet and you put in this formula right here. Equals norm MDST, parentheses, ZZZ, parentheses. And you place ZZZ with the z-score that you have, that you want to turn into percentile rank. So z-scores usually range from -4 to +4. Most of them are from -3 to +3, but sometimes it could be even higher, up to -4 and +4. But the range of a z-score, you remember the range is from -4 to +4. All right. You can also do the opposite. And if you have a percentile, you could turn that into a z-score. And the way to do that is to use this formula. Equals norm S, INV, parentheses, PPP, and parentheses. And you replace the PPP with the percentile value. Right. This value should be from 0 to 100. Actually, it's not supposed to be 0 to 100. It's supposed to be 0 to 1.0. Because percentile is less than 1. So like 0.5 is 50 percentile. 1.0 is 100 percentile. So for the sake of using it in a Google Sheet, you have to put the value between 0 and 1. Okay, so let's see how this might work in some example problems. So you see here, here's an example data set. And this is the same example we're working from earlier, where you're part of a sample of 200 people in a study about happiness. Everyone provided a happiness rating from 1 to 30. 1 means not happy at all, and 30 means extremely happy. So we have a few questions. For participant number 41, what is the happiness X value, Z-score, and percentile rank? This is need to be capitalized. Statistic number 16, what is the happiness value z-score percentile rank? For someone who has a z-score of 1.46, what is the x-score and percentile rank? For someone who has an x value of 3, what is the z-score percentile rank? For someone who has percentile rank of 93%, what is the x value and z-score? The last one is a sorting exercise, which we'll do in just a moment. Okay, so let's click on this and work through the exercise together. Here's a data set. You have participants on this column and their happiness level in this column. Participant 1 rated a happiness of 16. Participant 15 had a happiness of 15. So remember this from 1 to 30. You see down here, has 200 people. All right, so let's copy and paste these questions. Okay, this will come here. Okay. All right. For participant 41, what is their happiness x value, z-score, and percentile rank? Okay, participant 41. Let's go down right here. The happiness x value is 20. We can write this in here for now. We're still missing z-score and percentile. And I should move all this over. A few more columns so you can see it better. This one. Okay, that's better. All right. So how do we get the z-score and percentile? Let's go back to the lecture on the page. How do you compute it? All right. Remember, let's see. How do you compute a z-score from an x value? That is on this slide. Computing z-score. Remember from the x value? No, that's not. I don't think I need to label it. We'll just keep it z-score. Okay. This method is good for the data set. We have a data set, right? Remember let me copy and paste this instruction. So you see it here. Okay. In Google Sheets, enter the following formula. Equals xx minus m all over sd. Replace xx with a single x value, replace n with the sample mean, and replace sd with the sample standard deviation. Okay, well, we don't know the mean yet, and we don't know the standard deviation yet. Okay, so let's compute the mean and standard deviation. Okay, mean. Remember to compute the mean, put equal signs, average, and then you could just, and we're looking for the mean of the happiness variable, right? You could just click on the B, it just highlights everything. It doesn't matter, it highlights this empty cell, it ignores that. It doesn't matter that highlights the heading, it ignores that as well. Close parenthesis. So this B colon B just means I'm averaging the mean for the entire B column. Enter, you have 14.695. Okay, so let's only use two decimal points. So I'm going to click this to bring it down to 2 decimal points. So here the mean is 14.70. Right. Now we need the standard deviation. Remember the standard deviation formula is equal signs STDEV. And we need the standard deviation of the x variable, the happiness variable. Click on this again to highlight everything. and then enter. To make it easier for us, I'm going to label this as the X value. All right, we only need 2 decimal points. So here the standard deviation is 4.99. Okay, so now we have the formula. Well, all we need is the XX. So what I'm going to do is going to copy this here and paste it here. Remember, since it starts with the equal sign, it turns into a formula to compute. And we need to fill this XX with a value in the X cell and hit enter. There you go. And now Google has a suggested autofill where it basically just uses that same formula that we just put for the rest of these columns. And I want that, so I'll hit okay. So what we did here is we computed the Z value, right? So this is the happiness Z value. And this is too many decimal points. So again, I only need 2 decimal points. There you go. All right. So now to answer this question, the Z-score for X value of, for number 4, participant 41, the Z-score is what? Participant 41, the X value is 20, the Z-score is 1.06. Okay, what is their percentile rank? We still need to compute this. We can compute it here. There's the happiness percentile. How compute this compute Z-score directions. Okay, now we need to directions to compute percentile. Bold this to make it pretty, bold this heading as well. Okay, let's go back to the lecture and see how do you compute percentile. Z-scores, turn Z-scores into percentile. Okay, let's just copy this. Copy. And paste it here so we can refer it to it easily. Values only. Okay. In Google Sheet, enter the following formula. Copy. And remember, replace Z with the Z-score value. Okay. So double click, there's a cursor, right click and paste. Remember the Z is the Z-score here. And again, it gives us the option to apply the formula for the rest of the column. So yes, we want that. And I'll change this to use this. Check the decimal points. Okay, so this Z-score a point. So how do you read this? Look at this first participant. Participant 1 had a happiness value, X value of 16, a Z-score of 26, and a percentile of 60%. 60%. This might be easier to read if you hit the percentile button. You get 60%, and I don't need that many decimal points. 60%. So you could do either 60% or 0.60. It's the same. Delete these. We don't need these columns. So for the first question, for number participant 41, what is the X value, Z-score, and percentile rank? 41. X value is 20, Z-score is 106, percentile rank is 86%. That's the answer. For participant 16, what is their happiness, X value, Z-score, and percentile rank? Number 16, happiness, Z-score, percentile rank. Let's just copy that. Click, the cursor comes up, paste X value here, X value is 12, z-score is negative 0.054, percentile is 29%. Or for someone who has a z-score of 1.46, what is the x-score and percentile rate? So here we have the z-score. We have the z-score here, and then we need to find the x value and percentile rank. So the z-score is 1.46. How do you find that? So you could do a, I do Command F. Yeah, I do Command F, and it brings up the search bar. It's the keyboard shortcut for finding a sheet. And put 1.46, and it says it right here. It's participant 14. So for someone who has a z-score 1.46, what is the x-score and percentile rank? So the x-score is 22. Percentile rank 93%. Okay. For someone who has an x value of 3, what is the z-score percentile rank? So here we're given the x value, and we need to find the z-score and percentile rank. So we just need to look for a value of 3. So we can go again to the search bar, hit 3, and enter, go down this and see where we can find a 3. 3. There you go. X value and percentile rank. Let's just copy that. And paste. The z-score. For someone who has a percentile rank of 93%, where is their x value and z-score? So here we're given the percentile, right? And it's 93%. And we need to find the x value and z-score. So let's go ahead and look up 93% underneath the percentile. Here it is, 93. So we have x value 22 and z-score of 1.46. This x value. And z-score. Okay, last question. All right, sort the data by the hat. You see here how this data goes all the way across like this. It's kind of hard to read. So just double click on it and it'll bring it all into the screen for you. Okay, sort the data by the happiness X value from smallest to largest. Do this by selecting all columns in the data set, then select data, then short range, then click data has a header row, then select the X value column, finally click sort. And the question is, how many people are in the top 10% for happiness value? How many people are in the top 10% for the bottom, let's just say the bottom 10% for the happiness value? Just change that on there. Okay. So basically, we're trying to find the top 10%, the number of people in the top 10% for the happiness value, and the number of people in the bottom 10% for happiness value. But you see here the ranks, percentile ranks are all mixed up. They're not in order. Ideally, we wanted to say 1, 2, 3, 4, 5, 6, 7, 8, all the way down to 100 in numerical order. So the way to do this is just by following these instructions. It's long, it has a lot of steps, but this is how you would do it. You highlight all the column in your data set. Then you go to data, sort range. Then you put data has a header row because our data here has all these headers. And then you choose the column that you want to sort from smallest to largest, and that's the percentile. Oh, or the X value actually. Yes, I think the instruction says X value. It doesn't matter, it'll be the same, the sorting will be the same either way. It says A to Z here, even though we don't have any letters. A to Z just means from smallest to largest if you have numbers. and then you click sort. And you see here, now all the X values are listed from smallest at the top to largest at the bottom. Remember the score range from 1 to 30. No one ranked their happiness at the max level of 30. So I guess people here are extremely happy. Maybe they're like high average happy. Okay, so let's see how these X scores relate to the Z scores and the happiness percentile. Okay, so you see here, if you have X score 1, you're in the 0th percentile. That means there's no one who is more happy than you, for less happy than you. You're the most unhappy person in the sample. If you have an X score of 2, you're in the first 2 or 3, you're in the first percentile. That means you're happier than 1% in the 1% of the people in the sample. So you're happier basically than one person here. If you go down, if you have a X score of 12 on the happiness scale, you're at the 29th percentile, meaning you're happier than 29% of the people in this 200 people sample. And what's the highest? The person who had the Z score, X score of 25, they're at the 98th percentile. That means they're happier than 98% of the people in the sample. So they're very happy compared to a lot of other people. All right, what's the question asking? The question is asking how many people in the top 10% for happiness and how many people in the bottom 10% for happiness. Okay, top 10% includes blank blank people. Bottom 10% includes blank people. So I'm gonna okay, top 10% includes how many people? You see here the top 10%. This is the bottom 10%. This is the bottom 10% of the people. Is this these people? And you click on here to count 21. So bottom 10% includes 21 people. Bottom 10% for happiness level. Top 10% for happiness level. So top 10%, the happiest people are these people here, the one in the 90 percentile. Again, I'll click down here, look at the count 27. So the top 10% for happiness level includes 27 people. The bottom 10% for happiness level includes 21 people. And everyone else is in the middle. Okay, and you can see here that we have, I already did, this is the answer sheet if you click on the bottom here. And we can compare the answers, make sure we get the same thing. Copy, I'll paste it here. Okay, you see here, these match. This says 85, this says 86% as far as the percentile. That's just probably rounding error is probably fine. But you see here the X value and the Z score matches. Right here, X value is 10, Z score of negative 0.54, percentile 29%. X value is 12, X value, 12, yeah, X value is 12, negative 0.54, percentile 29%, matches. Yeah, everything else here matches. So we did good. All right, that is how you compute the Z score and percentile ranks. So I'm going to delete all this. So when you do this exercise under the exercise sheet, it's blank for you. But you can, of course, you can always refer to the answer sheet to get the answer. Let's go back to the lecture. That's it. That's the end of today's lecture about Z-scores. See you in class. Let me stop recording.